Hello, Internet. Welcome to the third video in our audio-reactive tutorial series. Today, we're diving into creating two interconnected audio-reactive waves with vibrant Glitchcore colors. These waves will move back and forth, forming a captivating infinite tunnel effect. I'm going to start this tutorial by giving a brief overview of the network and explaining some concepts. So let's start it. Chapter 1. Introduction. The first network is for creating a texture that we will use with the SOP operators. Here, we will create a texture through a ramp, then process the image with some common operators like level, and finally create an output that we will reference in a PBR material. But what is a PBR material? PBR means physically based rendering. This operator in TouchDesigner is used to create realistic materials by simulating how light interacts with surfaces. To apply a PBR material, you simply need to reference this operator in a material SOP. We'll cover this in more detail later, but essentially, by doing this, you are instructing TouchDesigner to apply the material to the geometry you are using. Next, in this network of SOPs, I will create a sphere, a line, a box, and another line. These will have a switch that will later react to sound, and depending on the intensity of the sound, one of these will be selected. Later, we have the classic and well-known network, which is used to visualize graphics in 3D. It consists of a camera, a geo component, an environment light, and the render to visualize. Finally, the instance technique, which I will explain to you in much more detail because it's the technique I want you to learn the most in this tutorial. So, let me explain how it works. To better understand how we will use instancing techniques in TouchDesigner, I will create another grid here. I will activate this operator by pressing A, then press P to show the display options, and finally press W to display the wireframe of this surface. Each intersection will show a coordinate. If I select View XYZ coordinates, I can see all the points of this mesh. Each of these points represents a coordinate in space. And what we will do later is use these points to instruct TouchDesigner to place an element at these coordinates. In this case, I will place a sphere, a line, or a box. In summary, instances are applied in the geo component and instruct it to use the coordinates of a surface to distribute elements at each vertex generated by this surface. This is not the only way to use instancing, but it is the method we will learn today. To finish, we will create an audio-reactive network where we commonly use the sound of the kick drum and the snare, and sometimes certain frequencies to manipulate the movement of this composition. Another important thing is to color code the operators that will have parameter modulation in red to avoid getting lost. This way, we will know which operators are being manipulated with audio and prevent confusion when working with larger networks. Chapter 2. Network. Very well. Let's start with a ramp operator and connect it here. Next to the ramp, we will use a level operator and connect it as follows. Next, we will create a null operator and place it a bit higher. At this level, we will add another level and place it directly. Finally, we will create a null operator and place it here. Copy these last three operators and paste them below. You can organize the network a bit if you like, and if you want, delete this one here as we won't use it. Finally, rename these operators. This one will be called emit, and this one color perfect. Finally, in this network, I will place a PBR material here, and we will leave it there for now. Let's move on to the next network, which is basically the core or the most important part for this project. We will create an LFO operator here. Perfect. Next, we will put a math operator and leave it here. Forget about these two operators for a moment and now create all the SOP operators. We start with a sphere. We will also create a line and place it below. Additionally, we will create a box and copy and paste the line to place it below the box. Next, to the sphere, create a switch operator and place it here in the middle, connecting these three operators to the switch. Perfect. After this, create a transform operator and place it here. Then, using the C key, you call this color panel. Assign colors and leave it in red to remember we will map this operator later. Now, create a texture operator here and add a material, placing it roughly at the same height. Next, create the classic network to visualize in 3D. Create a geometry operator, an environment light, and a constant texture to drag inside the environment and set it as an environment map. Then create a camera, and we can leave it here. Finally, create a render top, which will allow us to see the entire 3D scene. Perfect. Add a composite operator to the render top and connect the render top twice to the composite. This might sound strange, but you will understand later why we are using it this way. Connect a RGB level here to have a black background. Then, connect the level operator here. And finally, an out operator to see everything happening. Now we can see this sphere here. Perfect. You can organize this network a bit if you like. Let's move on to the next network where we will also use SOP's operators. So let's start by calling the grid and placing it here. Perfect. Next to the grid, create a noise operator, which we will duplicate because we will use it twice. Connect it as follows. Remember, they are connected in sequence. After the noise, create a null operator and call it clone. Select these two and change their color to red. Nice. Let's move on to the audio network, which is usually one of the most complex. I will drag this song I have here and place it more or less here. I will create an audio device out, but for now, I don't want the audio to be playing. I will go to the palette, look for the Tools section, and search for the audio analysis. We place it in our network and connect it as follows. Create a select operator and copy 3 times, arranging them this way. Okay. In the first select, create a math operator and then a lag operator, placing them like this. After the lag, create another math and finish with a null operator. Select the last 4 operators and copying 3 times. Perfect. For the second select, we will have a slightly different network. Start with the math operator, followed by a count, and add another lag. You probably guessed it already. We will place a null at the end. Rename these 4 operators with the following names. Let's continue with the last network, and with this, we will finish everything in the audio section. Create a lag operator and place it here. Follow this with a math operator and then a null operator. Place this operator a bit higher and create another math operator to connect to the last math we created. Rename these operators now. This will be called SW from switch and select SW. You will understand better why later. Finally, to finish this network, create a constant operator, duplicate it, connect a switch, and connect the second constant directly to the switch. Copy and duplicate this 3 times, arranging it here. For now, there's no need to rename these operators. With this, we have finished the entire network, and now let's move on to the next part. Chapter 3. Basic Settings. In this next part, we will cover the most basic settings. In other tutorials, you see me using almost all top operators with parent panel size. But this time we don't need that resolution, so we will leave it as is. In the second network, the only thing we want to do is set the render to the same resolution we are working with. So, if I go back to my project, I have this resolution. I want my render to have the same resolution. Change it to 1080 by 1920. Once you have changed the resolution, turn off the composite operator to see better what we have in the scene. Now that we have these basic settings done, let's start with the parameters. Chapter 4, Parameters. Here we will parameterize the ramp. I use some colors that I like, but in this part, as always, you can use any colors you want. I will quickly select some colors a bit randomly for each new key color selector. The important thing is that after doing this, it's a bit of an art, and the results can be a bit strange because we don't know how it will look. Then we will come back to change some colors and choose other things. Also, I have an excellent solution to make this process less time-consuming. But before that, let's finish setting up this network and then I'll explain. So I have already created some colors here. Simply, to create a new color, click anywhere in the empty space. And if you want to set or move any of these colors, just click and drag them to select the color you like. This is quite intuitive and easy to do. Perfect. I have my first ramp, which we will use later, and this level can use any parameters you want. I will copy these numbers because I know they will work for me later. Finally, for this level here, I want it to be a bit brighter than the rest of the texture, so I will just increase the color to 1.5. Now, let's move on to the solution I have for creating colors and palette keys in a much more interesting way, instead of spending time selecting each color by hand. If we want a super interesting palette, I have created a component using Python that allows us to generate a color palette from any image or video. I will bring this component forward, and all I need to do is create a movie file in, connect it to the component. Click Get Palette. It will take a bit of time only the first time, but then it's practically real time. I will call other images I am interested in using to show you. I will bring a different image that I want to use, and if I click Get Colors, I get all these colors. The interesting part is that in this output, if I create a null, you will see that this null will give me a ramp, and this ramp is created with the colors from here. If I want, I can also do this with videos, so let's load a video quickly, for example, this one, and I can get the color as the video changes. This makes it very interesting. I will stick with first the image that I will use in this tutorial. I will bring this palette directly here, create a null again, and possibly replace it here. Now, these settings should change because they are too exaggerated and might not work as I need them to, so I will leave them at default values, and that will be enough. If we don't like this palette, we can come back and reconnect this, but for now, let's leave it as it is, and later we will explore what other options we have. Perfect. Let's move on to the next network we have here, and here we will use the following parameters. For the math operator, use these parameters. We will map this to the size of the sphere later, but for now, leave it as is. Now select our sphere, and the most important thing is that we will work with polygons because we want our sphere to have the least number of polygons. In detail, we will leave it at 2. You could set it to 3, but it depends on the frames per second you see here, so keep that in mind. The rest will be left as is. For the line, use these parameters. For the box, change the size to these numbers. Perfect. For the second line, set it to 0.4. Texture, the only important thing, is to set the texture type to cylindrical. The rest will remain identical. Before moving on, I want to show you why I chose this texture type. So let's skip a bit ahead and map these colors to the PBR. Go to PBR operator, select Maps, drag the color to the base color, and the emit to the emit. Now go to the RGB tab, select emit, set it to white, and now we can see the color we will use. This PBR will be referenced to the material, so select the material, click on PBR material operator and drag it here. Now we can see how the material we created is applied to the sphere. If you want, go back to the sphere and add more detail. When you select the texture, as you can see, the most classic option is XYZ normalize, which is the most common option. But in this case, it will work better to use this. For now, understand that the type of texture and how we will apply it has different ways of mapping the texture's color to the material. This texture operator is super interesting because it allows us to choose between different ways of mapping our texture, or even you can change the size of the texture and so on. I will leave these default values and move on to the other parameters of the network. In Composite, we can turn it on if we want and select the blend type over. In Level, let's use these parameters for now, even though it's not the best time to do so, and we will change them later if I needed, so use this parameters or now. We have finished this part. Let's place ourselves in the third network, which we will use to make all the clones. Select the grid and copy these parameters exactly. Remember that the more rows and columns you have, the more subdivisions you will create, and therefore the more instances your project will have. Keep this in mind because very high numbers could cause your PC to crash or significantly reduce your frames per second. In noise, make sure we have this animation created here by default. In the second noise, make sure the same thing is happening. Here comes the most interesting part, where things get much more interesting. So first to do this, let's go back to our sphere and change the frequency to 2. Select sphere and change the size to 0.01. We will have a practically tiny point here. Select our geo object, go to the Instance tab, turn it on, and we want this point to be located at each point of this grid. Remember the explanation earlier? And each of these spheres will be placed at each of these coordinates. Select Geo and drag this null called Clone in the option Translate OP. The X coordinate corresponds to point 0, the Y coordinate to point 1, and the Z coordinate to point 2. Although right now the grid doesn't have a Z coordinate, the noise is manipulating it, which is why we have this movement. For now, to understand everything we will do, I will turn off both noises. I want you to see how this looks. Additionally, if we go to the camera, open it with A, we can see all these spheres being cloned at each coordinate. I have an error with the sphere. It seems the size is not right. It's missing a 0. Perfect. Now we can see each of these spheres, which also has a specific texture mapping, is represented at the points, at the coordinates. If you want to return the camera to its original position, just press H. You can zoom in if you want. Now we see these instances. Remember that the number of instances is multiplying 150 by 120, which gives us a total of 18000 tiny spheres. Check that if you exaggerate this number, it may start to strain the computer's resources. Very well. Let's review the parameterization of the audio network. Let's start by turning on the audio to listen a bit and go to our audio analysis tool. The first thing I will do is activate the frequency parts I need, in this case, high and the kick and snare. Now I want the high frequencies a bit more aggressive. I will increase the threshold sufficiently in the snare, maybe completely until it has a reduced number of repetitions. I can probably fine-tune this later, but for now it's quite good. Now let's work with our first network. The first thing we will do is go to Select and use only the kick. Now, And we will manipulate all these math operators. Before doing that and having you copy the parameters as we usually do, I want to show you how this network works and why the decision for the values we will use next. I already did this in previous tutorials, but it's important to see it again. Let's create a trail and leave it here. Obviously, I already know that kick gives me a Boolean value of 0 to 1. The log interpolates values, and this 0 to 1 becomes something like 0 to 0.8 approximately. If I want to know the exact maximum value, you need to create an analysis operator, set this value to maximum. As you can see, the maximum value is 0.83. Let's keep this information here. After this lag, I have another math operator. Now that I know the signal has a maximum peak of approximately 0.82, I need to set this range in the math operator. By doing this, I will ensure that the output values from the math operator are as close as possible to what I need. I will show you once what I'm doing. This AMP will be mapped to the amplitude of the noise. How do I decide which values to use? I have two ways. One is to map the value directly to the noise and see what happens. We see it's interesting, it works, but I would find it more interesting if the effect from the noise never completely disappears. So I go to the math operator and tell it that I want my range to go from 0.2 to maybe 0.9, and I keep testing and checking to see what works best. That's one way to do it. The second, which I find more interesting, is to see the values here and simulate with the mouse what I want to see, how I want the audio to interact with this shape. For example, I find it more interesting if the amplitude never completely disappears to a minimum of 0.2 and a maximum of 0.8, maybe 1.1. This might be too much for some things, but we won't cover it in this tutorial. So I think the values I will use are 0.2 to 1. So I go to this math and set it to 0.2 to 1, and I will leave this mapped for now because, as you know in my tutorials, I prefer to do things in sequence and mapping would be the last thing we do. But for now, this value is mapped. I will delete this here and continue with the parameterization. We know these are 0 to 0.82. And now I will parameterize the lag by selecting the first log and copying these values. The second and third lag will remain as they are. Select the second math in this network and copy the following values: 0 to 1.2. Do the same for the next math, 0 to 1.2. This is ready for when we map the values. Perfect. Let's move on to the next select we created here, this network, where we will use the high frequencies. And for this math first, let's find the ideal range by creating a trail. But it's better to create an analysis and set the maximum, seeing it's 4.8. So this math goes from 0 to 4.8, and each time at the high frequencies hits 0, this threshold will count some one number. I will delete this and simply set the lag to 0.2 and choose lag magnitude, which I like to use. And check these as well. In fact, select lag magnitude on the operators above as well. Perfect. Notice how the lag changes the feel significantly? It's quite different. So this lag will interpolate these values. Now, create a trail to see what's happening with these values and see they are continuously advancing. Each time a high frequency sounds, let's active the audio for a moment. I think it's very interesting not to have a super detailed formula for everything, but to start exploring. Later, we will map these values and I'll tell you how. Perfect. Continue with the last select. This select will use the snare. Again, we have values from 0 to 1. If we create a trail and an analysis, we already know what's going to happen. Copy this, create an analysis as well, and set the maximum. We know it's 0.8. It repeats the same as with the kick because they are Boolean values from 0 to 1. Now let's go to math Delete this and copy this values. Remember, here there's only a null and a select. These operators will help me select the changes I want to make. The first thing I will do is go to this math operator and set the values to go from 0 to 4 because I want to use them in the switch operator. The switch has an index that ranges from 0 to infinity in whole numbers. So I need to tell this math operator to work only with whole numbers by setting it to floor. Now we have values from 0 to 4, and in the select below, I want values from 0 to 2. I have decimal values, but normally it works fine. Let's create a trail to see what happens, and we see we have something like 0 to 2. There are intermediate values, but this won't affect us later. Perfect. These constants I created here are values that we will use to change a parameter in a binary way. We will have two values mapped to a parameter, and these will be selected with a switch, which will decide which of the two values in the composite will be assigned to the parameter. This is a super interesting way to make sound generate other types of reactions. For now, we will copy the following values I will use in each of these constants. Copy all these values. Perfect. What happens with the switch? Right now, the switch is selecting the first value, and if I set it to 1, they will automatically choose the second value. If I go to the switch below and want to select the lower value, I set it to 1 and select it. If we do the same with the last one, which is currently set to 10, select 1, it will choose -5. You will see how this applies in the network. We are very close to having the result we want. Let's move on to the next part. Chapter 5. Referencing parameters. Very well, we are doing great. Let's start mapping. The first thing I want to happen is for this math to apply to the size of the sphere. So select the sphere SOP and reference this math to the sphere's radius. All spheres are moving practically at this frequency. I will make it slower for now and move on to the next mapping. In the transform, the only thing we have is that I want the spheres to rotate, so the color mapping we did with the activation is in constant movement. This will create a very subtle effect, but you will notice it in the end. I will go to rotation, to the z-axis, and show you something interesting. If you press Ctrl E, you can open your text editor and write the script we will use here, because it's much more comfortable than how we've done it before. So use the script abs time.seconds multiply by 150. Press Ctrl S to save and close the window. That's one way to do it. The other is to write it directly here. It depends on how long the script you are going to use is. Now let's go to the camera. The spheres are constantly rotating, and that already creates movement in the polygons, which is also super interesting. I think it's time to set this camera in the position I want to have. Let's leave it there. Perfect. Let's move on to the next step. Luckily, to avoid getting lost in this tutorial because it's more complex than the previous ones, I colored these operators red to know what to map. So let's continue mapping. We already mapped the amplitude, and the next thing we will map is the exponent. For the exponent, we will use the exponent here and map it directly here. This creates super interesting movement that we need to remap because it's too strong. Now I can come here and tweak some things and start moving this, for example, to see what works and what ranges work. Also, I can come here, disconnect the exponent, and see what interests me and what ranges I want to work in. So I want it to go from a larger number to a smaller number, but the smaller number should not be strong enough to break the shape. For example, this doesn't work for me in this composition, so the minimum number I will use is 1, and the maximum number is 3. I go to math and set it from 3 to 1. Now let's map the exponent again here. Perfect. Now we have the movement we are interested in. The next mapping is extremely interesting and can be a bit confusing, so I will take the time to explain it. Go to Transform, and I want this texture to move constantly. I could use the abstime.seconds script and copy it here. Now, I see the frequencies generated by the noise are constantly moving. What if I want these frequencies to move with this counter we created before that reacts to the high frequencies? I need to do the following. Map the counter here, and now it will move each time a high frequency sounds. I think it's valid to turn on the sound now. See how it travels. You know what? I will make the spheres a bit smaller so it's easier to understand what's happening. Even smaller. I think this looks better. So what we will do is remember we set high frequencies here. Now, I want this to move constantly, and not only when high frequencies sound. I will add abstime.seconds, Control E, save it, and now it's moving constantly. Now when a high frequency sounds, it pushes the movement more, which looks super interesting. Now comes one of the best parts. If you see it's moving from back to front, I want it to move from front to back when the snare sound plays and continue its path when the snare sound stops. To do this, if I multiply by a negative number or a positive number, I will achieve this effect. I need to reference this and multiply it by these numbers. Remember, here I have a positive number and here a negative number. I will show you a trick to do this. Map this wherever you want, for example. Here in the pivot parameter, this is just to view the reference text created when an operator is referenced to a parameter. Copy the reference of this mapping and multiply in the script over here. If you click here and use Control E, it will open the text editor, allowing you to see the script we just created more clearly. Remember I said that when the sound plays, it changes direction? To do this, I need to change the switch index from 1 to 0. See how it changes direction. This is super interesting. We created this select switch to go from 0 to 1, which I will map to this switch. Now each time the sound plays, the texture stops and moves forward. I prefer this to take a bit longer because the effect is too subtle. So I will try this now and see if it works better. Let's select lag magnitude, and this is perfect. Much better than I wanted. Map this select to the other two switches as well. Now let's map the following values. Remember, we still have this XP2, which I will apply to the second noise. But before that, it would be important to play with the camera and set it in the most appropriate position. I need this to look better. I will zoom out with the camera. Again, I think I should change the sphere size because it still looks too big. Let's map the following. We have this free X2, which we will map to the second noise currently off. Let's turn on this noise first to see what's happening. To avoid this abrupt movement, we will chance the noise to the following parameters. Now let's map the exponent. Take this second exponent and map it here. Now we see something extreme is happening. Let's go to math and set it from 3 to 1. Much better. Sometimes it's hard to appreciate what's happening, but if we turn off this first noise, we see what the second noise is doing in parallel with the first. Super interesting, right? Now the next parameters will be the period which I want to set when the snare sounds to break all instances and create this glitchy effect, and when it's not sounding, to keep it in a place where the composition looks better. So let's map the value. Let's map this directly to the value here. Did you see how the snare breaks everything? This is great. I really love this. Now let's do the same with the amplitude. Map the other switch we have here. It breaks the pattern a bit more. And remember, these depend on the snare's sound. I also want this second noise to have movement, so I will turn off the first noise to see what we want to do. Let's go to transform. Open this and copy the abstime.seconds here. Now we have left to right movement. See how it shifts, and on the y-axis, I will use the same script I used here. So I will copy this and paste it here. Now I have the same thing happening, where depending on the sound, this will advance or retreat. Now we have all the most important mappings. Let's turn this on and turn on the music. Very well. Let's add one last switch because this switch must also change with the snare sound. For this switch, we had this last switch going from 0 to 3. Selecting between the circle, lines, box. In the second line, we will change dimensions later. Select the switch, go to our switch here. If you want, name it soft switch to remember and map it to the switch here. Now we have these incredibly wonderful glitches happening. Perfect. Let's move on to post-processing to finish this project. Turn off the music again and go to this composite. Remember it? Go to transform, and the only thing we will do is rotate by 180 degrees. Obviously, we will also shift it until it's in the position we want. More or less there, I think that's interesting enough. Now we need this to have more color and presence. For that, we need to increase the sphere size again. It could be 0.01, or we could use the original values I had before. They are much larger. Now we have more texture. The density of what we see can be adjusted here because remember that the coordinates of the grid are what we see now as density. We will lower it to 100. Let's see how 50 looks. Here we have something more subtle, and it's better to see it this way because we can better appreciate the movement. I think from here on, it's interesting to start manipulating these two matrices and see what interests us most. I also think it would be interesting, since I changed the size many times, to set a transform here and do it directly here using the scale parameter until we find an intermediate point that works. This is quite good. Okay, let's move to the final part. Chapter 6, Playing and Explore. For example, the second noise is interesting because we can start to play with harmonics, the same with the first noise, for example, the period. The noise can be much more intense. Another thing we can do is go to texture. Change the texture type and see how the feeling changes here. Now let's return to the colors. Remember, we created this color map. We have to see it this way. We already have different colors. They are more like what we want. In post-processing, it's now worth going to the last level and starting to play with contrast and brightness. This looks super interesting now. Remember, this composite is like a mirror of what's happening above. But if I move the camera, many different things can happen. We can test this. What happens if I start moving the camera? Some things will look weird and some will work well. I think this depends a bit on how much we start playing with it. I hope you were able to complete this tutorial. It's undoubtedly the longest and most demanding one I've done so far. As a fan of audio-reactive techniques, I will continue exploring and presenting more tutorials. Please leave your comments if you have any questions or if you succeeded with the tutorial. Remember, the project file is available on Patreon. Don't forget to subscribe to the channel and click the bell icon.